Hello, everybody. It's Mrs. Pound, and I'm back with another chapter, chapter 4.1 on water. And we're going to be discussing water because water is just so important for life on our planet, and most of our planet is covered by water. So, in order to understand why water is so important for life and on our planet, we have to first take a look at its properties in section 411. So here is a water molecule, and you will notice is you should all know the chemical formula for water is H2O. So two hydrogen atoms bonded to an oxygen atom. And this bent structure is very important because what this means is that water is polar. It has partial charges on it. So the hydrogen atoms have a partial positive charge, and the oxygen atom has a partial negative charge, making this a polar molecule. And it's because of this polarity and these partial charges and this bent structure that water has certain properties and certain properties that God created it to have in order for life to exist on our planet. It's these special properties that allow water to exist as a in all three states on our planet as solid, liquid, and gas. At room temperature, especially the fact that we have liquid water. Liquid water is crucially important for life, as you know, you are mostly made of water. So, the first important property of water is cohesion. This is the molecular attraction between particles of the same kind. And we can see here dew on a leaf has formed, and it is cohesive. It is sticking together because the partial positive on the hydrogen atoms is attracted to the partial negative on the oxygen atoms. So they stick together because of that. A lot like magnets with the different poles, the north and the south poles, how they stick together. That's what water molecules do with the charges because remember, opposite charges attract. This also produces surface tension. This is the force that pulls molecules on the surface of a liquid together to form a layer. And so creatures like this water strider can be on the top, or leaves can float. And that is because on the surface, there are fewer hydrogen bonds. There are fewer molecules for the surface molecules to bond to, and so those bonds can be stronger because they're concentrated. There is also adhesion. This is the force of attraction between different molecules. An example would be water and plant roots. And you can see down here that curve that we always look for in our graduated cylinders that we also see here in these test tubes. That's called a meniscus, and that's because the water molecules are sticking to the side of the test tube. Now, remember, this is also due to charges, and so not only will water stick to itself because of these charges, but it will also stick to other things when there are charges present, especially even partial charges that would exist in the glass. Another property of water, due to its these hydrogen bonds that it forms because of these partial charge attractions between the molecules, is specific heat. This is a substance's ability to absorb heat energy. These hydrogen bonds between water require a lot of heat energy to break them up. So on a hot sunny day, they will absorb and absorb and absorb that heat. Some of the water will evaporate. Some of the heat will disrupt the hydrogen bonding and allow it to evaporate. But a lot of that heat just becomes stored in the water. And so the water actually has a moderating effect on the climate of our planet. It will store that heat and then it will release it, say, during the night or in the winter or actually in the fall more, we have a longer growing season here by the Great Lakes because that heat is released by the Great Lakes on to the surrounding land and will keep it a little warmer. Also, the opposite effect will happen in the spring. It will keep things a little bit cooler close to the lakes, but then it will heat up and also produce that longer growing season. So it has a very moderating effect, and the oceans do the same thing. It's also called the universal solvent because it dissolves many things. However, we do have to remember that like dissolves like. So, water will dissolve other polar substances. It will also dissolve ionic substances that have a stronger charge than just a partial charge. It will dissolve ions with positive and negative charges. So, it will not dissolve nonpolar substances, though. It will not dissolve things like oil. Okay. So it doesn't dissolve everything, but it dissolves a lot of things. Also, the fact that ice floats on water. This is very important for our aquatic ecosystems because if ice sank like we would expect most solids when they change from a liquid to a solid, they become denser and they would sink. But water, because of that bent structure, actually that bend in the molecule widens when water freezes, therefore reducing the density, allowing water or ice, excuse me, to float on water. And what this does is it prevents the ice from sinking to the bottom and crushing all of the plants and organisms that live on the bottom. So that is a crucial thing with water, the fact that ice, its solid form, floats. Now, the polarity of water helps maintain the percentage of dissolved oxygen in lakes and ponds as well, because water molecules form strong hydrogen bonds with other water molecules. The partial positive region around the hydrogen atoms is attracted to the partial negative region around the oxygen atoms, as we've already stated. A lot of energy in the form of heat is required to separate these hydrogen bonds, that specific heat capacity idea. On a sunny day, heat absorbed by the water will cause some of the hydrogen bonds to break, releasing dissolved oxygen. However, the high specific heat of water prevents all of the water from evaporating. The remaining water has enough dissolved oxygen for some organisms to survive. So that kind of combines a lot of those different properties that we talked about with the hydrogen bonding and the high specific heat capacity, as far as even organisms like our fish and other water organisms to survive in lakes and ponds. So, just water is so crucial to life on our planet. So, our objectives were to describe the various life sustaining properties of water and explain how polarity affects water's physical properties. So, don't forget your 5 questions, and I'll be back with more on water.